Hello, friends and students. Welcome back once again. So, in today's class, we are discussing one more project. A new project idea that has come to my mind and I have transformed it on the screen. So, name of the project is Automation of IoT-Based Classroom, integrating light fan control. Usually, we will control lights and fan in a classroom. Temperature monitoring and entry management using ESP32 and microcontroller. That means entry management is done with the RFID, and the microcontroller we have used is ESP32 microcontroller. Okay. And this all these things we can have it a web server. That means we can check all these parameters as well as control from a web server. So this is a project used for latest classrooms where the students will be allowed in certain up to certain time, and apart from that it will be the lights and fan, all these controls will be automatic inside. Okay, so this is the project name, and we'll go to the next slide. Okay, so we'll just have an overview. This project automates a classroom environment using ESP32 microcontroller. It controls lights and fans based on presence and temperature, monitors environmental condition, and manages entry using RFID and tags. Okay, that means if valid ID is there, then only you can enter the classroom. Our dashboard allows real-time monitoring and manual control. Okay, so we have IoT project where we have used ESP32, which controls a classroom that is called a smart classroom. Okay, let's go furthermore and study about the things and all. Okay, what are the components used for this project? So we have used ESP32, of course, it's a development board. DST11, same time you can see the picture also on the right hand side. Relay modules, or in my case, I have used a LED instead of a relay. I have used an LED for indication purpose. Okay, then we have used an RC522 RFID module, that is 13.5 megahertz frequency, which works on that particular radio frequency, and OLED display, right? A small OLED display. LEDs are used, of course, 2 or 3 LEDs are used. One is for indication of light and one is for indication of fan. And another is indication for allowing the student to enter. If it is not allowing, then one light will come for that. Okay. Then you have a push button for reset. Of course, we can do reset from the microcontrol itself. Breadboard, jumper wire, and power supply of 5 volts. So this is a simple schematic diagram where I have used DST11 and a RFID with the 3 LED and a microcontroller. That I have just kept it like this and I have shown it to you. The details will be shared, that it will be, the details will be in your when I will share you, the codes at that time, the details will be present at that particular time. So what is the functional feature about this? Automatically the light turns on off, fan light based on temperature threshold. So I have kept a threshold of for switching on the fan to 40 degrees. That means if it crosses 40 degrees, automatically the fan will start. Okay. And RFID-based authorized entry will be there. No entry for unauthorized card or ID holders. LCD OLED shows temperature, humidity, light, fan position. Okay. Web interface display real-time temperature and humidity, on off button for a fan and light. Of course, button is there. IP address printed on the serial monitor. Okay. So these are the facilities which are there. Now let's go to the our lab and check the things around there.
Alright, as you can see in this video, the OLED display on the left hand side, you have ESP32. I have used temperature sensor and one RFID, right? So this is your RFID, this one is your RFID, right? There are 3 LEDs over here. The 2 LEDs, in fact, this is for one is for a fan and one is for light, and this LED is for not granting the access. If the access is granted, this light will not come. If access is not granted, this light will come. So let's have a demo. First of all, I will give you non this thing. That means I'm putting a card. This is my card. Okay, the yellow light has come, that is showing that automatic the fan has started. Why? Because the temperature has caused 40. Right, the temperature has caused us 40. So let's try to show it to you. Alright, I will just try to take the card near to me. You can see the light has come over there, blue color. That means no excess. And I am putting another card over near to that. That will give me the excess. Okay, this is gives you the excess. Okay, so the same thing we will check it on the web server, but you have to see whether the this access is not access is denied, like blue color light is that. Okay, now through web server what we will do is we'll try to control the lights, the fan and the lights. Please remember the fan is directly connected to the temperature. That is, when the temperature crosses 40 degrees, automatically this fan will switch on. Okay, so I will just try to show it to you. This particular, I will just put my hand on this and let's see whether it crosses 40 degrees or not. All right, so let's see whether this thing comes up or not, the yellow color light, because temperature has to go high for that. Okay, then only it will come. Yeah, it has come now. The temperature has gone high, so automatic the fan has started. This is smart classroom, smart lab, or smart system for any of the labs, classroom, you can say college, anywhere we can use it. All right, so this is about this thing. So let's try. Alright, I will just try to take the card near to me. You can see the light has come over there, blue color. That means no excess. And I am putting another card.
So this is our code for smart classroom control. So in the beginning, you can see all these are the libraries which you should have. That means all these are the library, because we are using a different type of MFRC 522H. Then you have Adafruit GFX and Adafruit SST 1306, because these are the display ICs. This MFRC is your RFID. Then we are using web server. That's why we need the Wi-Fi H as well as web server H. And DST, of course, we are using. And since it is connected in serial, so we need that library also. So first of all, you have to give your SSID and password. After giving your password, SSID and password, here we have defined the different pins which are connected to different this thing only, and the screen, about the screen details, OLED screen detail has been given over here. And next is your component detail, DHT pin and RS pin, MFRC pin, and web server. That is the channel output it is working. Then void setup. In void setup, we have given a baud rate, and we have just described that fan pin and light pin, which is the output pin, LED pin. That is, if you are allowing somebody or not allowing, then accordingly there is a LED pin for that. Or okay, so these are all the details. One more thing I would like to tell you about here is this is on and off, and one more thing where I have kept the threshold point. Okay. So threshold, you can see here, I have kept the threshold to 40 degree. You can change it to whatever requirement you want. So accordingly, you can adjust it. And finally, when you load the code, select the board and like do it ESP development kit V1. I have used it. And finally, I've got this one. That is, I've got this ID. Okay. And of course, there is a card pin which has been scanned, and whether it has been denied, first it has been only what scanner it has been allowed to enter, or otherwise it is denied. Okay. The light is also there for the denial purpose. So you can see on the web using this IP address. So this is the code part which I'm going to share with you.